this video, I want to talk about pH, pOH, and I'm going to do some examples that involve calculating pH. So let's just go over very quickly a few points about pH and pOH. So pH and pOH, they're a unitless way of expressing the hydrogen ion or hydronium ion concentrations and hydroxide ion concentrations. And it was introduced in order to deal with small values of concentration, like 10 to the minus 9, for example. And we know that that pH is equal to the negative log of the hydrogen ion concentration, and pOH is equal to the negative log of the hydroxide ion concentration. And it's very, very important to note that any numbers that come after the decimal in a value of pH are significant figures. That's very, very important. So what I mean by that is, for example, if we have a pH of 3.74, there are actually only 2 significant figures. So let's do a couple of examples. So we're going to be calculating the pH for each. So in the first part, we have a hydrogen ion concentration of 2.8 times 10 to the 4 moles per liter. So this is quite simple. All we have to do is we just substitute this hydrogen ion concentration into the above expression, and that will give us the pH. And if we do that, we'll end up with pH of 3.55. And remember, this has 2 significant figures here. It must have 2 because the original hydrogen ion concentration also had 2 significant figures. And we'll do one more. So we have a hydrogen ion concentration of 5.10 times 10 to the negative 10 moles per liter. And again, we just substitute that into the above expression for pH. And if we do that, we will find that the pH is equal to 9.292. And in this case, we have 3 significant figures in the pH value, because in the hydrogen ion concentration, we also had 3 significant figures.